started.
Alright, so this is lesson 71, and I might do a couple of examples. So we've been finding the area under a curve using integrals. So here's my curve, and I want to find this area right here. We know that that's the, this is f of x. We know that's the integral from a to b, f of x dx. So that's just the area, 2 by 2, or two-dimensional. But lesson 71 is going to talk about three-dimensional volumes. And they have, look at your book on 71, they have some very good drawings. And you'll see where this area right here is rotated about the x-axis to make a three-dimensional figure that we find the area of. And so the figure is split into discs instead of rectangles. They're split into circles or discs. And so for that, we're going to take the integral from a to b of the area of the circle, which is pi r squared dx. Well, we don't need dx yet, but because the radius of our disc is going to be our f of x, so we can rewrite it as the integral from a to b of pi times f of x squared dx. So on that first example, they show that the area that's being rotated is bounded by this triangle here, which is formed by the x-axis, the y-axis, and y is equal to negative x plus 1. So negative x plus 1 is our f of x, is our radius. So to find the volume when that is rotated over the x-axis, then we do the integral. We're going to do from 0 to 1 because that's the graph. Pi times our radius is going to be negative x plus 1 squared dx. So remember, pi is just a constant, so we can move him on the outside. I'm going to come over here so I got a little more room. From 0 to 1, negative x plus 1 squared is going to be x squared minus 2x plus 1 dx. So we're going to have pi, and we're going to evaluate this. We add 1 to the 2, make it 3, divide by 3. Minus, we add 1 to the 1, make it 2, divide by 2. Plus, we add 1 to the 0 that doesn't show up, and it leaves it with x, and we're evaluating it from 0 to 1. So we've got pi times 1/3 minus 1 plus 1, and we would do minus the 0, but that's going to be 0 minus 0 minus 0. The minus 1 plus 1 goes away, so we've got 1/3 pi units cubed. Alright, thank you very much. Stop it.